Lesson 2D, Ionic Compounds. Ionic compounds are pure substances where metal is chemically combined with a nonmetal. It requires metals losing electrons to create positive ions, and nonmetals gaining electrons to create negative ions. The bond is due to the electrostatic attraction of opposite charges, like how opposite poles of a magnet are attracted to one another. Let's look at NaCl. Sodium is on the left side of the periodic table, where the metals are found, while chlorine is found on the right side of the periodic table, where the nonmetals are found. CO2, on the other hand, is created from a chemical bond between carbon, a nonmetal, and oxygen, another nonmetal. This is not an example of an ionic bond. Rather, this is a covalent bond, which we will look at in later lessons. In the case of sodium and chlorine, sodium will lose an electron, allowing its L shell to become its complete valence shell. Doing so results in sodium becoming an ion with a positive 1 charge. Elemental chlorine, on the other hand, has 7 valence shell electrons, so it will gain a single electron to complete its valence shell, the M shell, and in doing so it will become a negative 1 charged ion. These opposite charges will create an attraction between the two atoms, which will result in a chemical bond. Note how the sodium ion has a positive 1 charge, and when it binds to the chlorine ion with a minus 1 charge, it creates an ionic compound, NaCl, which has no overall charge or no net charge. The single plus 1 charge is neutralized by the single negative 1 charge. In this example of sodium ion combining with fluorine ion, their plus 1 and negative 1 charges means that the ionic formula will require a single sodium and a single fluorine ion. This will create a neutral ionic compound, NaF. In this case, where magnesium ion has a plus 2 charge and bromine has a minus 1 charge, the neutral compound must have 2 bromine ions, each with a charge of negative 1, to neutralize the single magnesium ion's positive 2 charge. The result is an ionic compound with the formula MgBr2. A shortcut to figure out the number of each ion required to create a neutral ionic compound is called the Crisscross Method. First you write the metal ion and then the nonmetal ion along with their charges. Then you rewrite the metal and the nonmetal without charges or subscripts. Next, take the ion charge from the metal and rewrite the charge as a nonmetal subscript. This is called the Criss step. Do the same for the nonmetal's charge to the metal. This is called the cross step. The formula is now Mg1Br2. We do not write the subscript 1, so the formula is simply MgBr2. Try barium ion charge positive 2 and oxygen ion with a charge minus 2. Crisscross and it becomes Ba2O2. With ionic formulas, we get to reduce, so the formula is simply BaO.